Hey, welcome back. This is episode 21 of the Salesforce Agentforce Masterclass. Today, Agentforce DevOps and Lifecycle Management, ALM. Architecting Enterprise CI/CD Pipelines for Autonomous Agents. Let's get into it. Here's what we're covering today. Understanding Agentforce metadata types, bot, GenAiPlanningRuleset, GenAiPlugin, then, the Dependency Web, how topics, actions, and prompts interconnect, then, Scratch org configuration for autonomous agent development, then, version control and Git branching strategies for AI agents, then, building CI/CD pipelines, deployment order and validation strategies, then, post-deployment steps and activation automation via Apex/CLI, then, testing and validating agent integrity in target orgs, then, rollback. Strategies and monitoring agent drift in production. Stay for the last one, it's the piece most tutorials miss. Let me explain this simply. Hey everyone, welcome back. Today we are tackling the ultimate enterprise question. Once you build these brilliant autonomous agents, how do you actually deploy them across sandboxes to production without breaking their brains?
Exactly. I can easily build an agent in a sandbox, but how do I package its instructions, topics, and actions using standard CI/CD pipelines like Git and SFDX?
When you look under the hood of Agentforce, you aren't just looking at one single configuration file. It's actually a collection of highly specialized XML metadata files. Think of the bot metadata as the chassis of a car, while the GenAiPlanningRuleset acts as the onboard computer guiding the driving style, and the GenAiPlugin files are the modular engine components. Understanding this relationship is critical, because if you deploy a bot without its corresponding GenAiPlugins, the agent will deploy successfully but will act completely brain-dead in your target environment. Let's talk about dependencies, because this is where most deployment pipelines crash and burn. An agent is a web of connections. Your GenAiPlugin might call a GenAiPlugin action, which points to a prompt template, which is grounded on a custom object and backed by an Apex class. If you try to deploy the agent's bot metadata first, Salesforce will throw a validation error because the underlying actions don't exist yet. Think of it like building a house. You must pour the concrete foundation, your flows, Apex, and objects, before you can install the smart home automation system, which is your agent. Setting up the right sandbox strategy for Agentforce is like setting up a safe training ground for a physical robot. You cannot develop agents in a vacuum. To enable Agentforce in your Scratch orgs, you must explicitly declare features like Einstein and GenAI in your Scratch org definition file. Furthermore, because agents rely on natural language grounding, developers need mock data seeded into their environments. Without real-looking accounts, cases, and orders, you can't realistically test if the Atlas engine is picking up the right context during your local debug runs. In a multi-developer environment, Git branching strategies can get messy quickly. Imagine two developers modifying the same topic instruction. Merging those XML files can feel like trying to untangle a pair of headphones in your pocket. To avoid this, treat each GenAiPlugin as a separate functional domain and assign them to distinct feature branches. When reviewing pull requests, remember that you aren't just looking at standard code syntax anymore. You must also peer review the natural language instructions to ensure no one accidentally introduced prompt injection vulnerabilities or vague directives. Now let's build the actual pipeline using GitHub Actions or GitLab CI. The secret sauce is three-phase deployment sequencing. In phase 1, we push the underlying infrastructure, things like Apex, Flow, and named credentials. In phase 2, we push the AI logic, including prompt templates and model builder integrations. Finally, in phase 3, we push the agent metadata itself. If you try to deploy everything in one single, unsequenced block, the Salesforce Metadata API will often throw transient reference errors, because it tries to compile the agent before the actions exist. Once your metadata lands in a target production or staging org, it's typically deployed in an inactive draft state. You don't want your release managers manually clicking Activate inside the setup menu at 2 a.m. To solve this, we can use automated Salesforce CLI commands or lightweight post-deployment Apex scripts to trigger the activation programmatically. This ensures that the newly deployed version of your agent is immediately wired up to your live messaging channels, ensuring zero downtime, and eliminating human error during the critical go-live cutover. Validating traditional code is easy, it either passes unit tests or it doesn't. But how do you unit test a brain that thinks non-deterministically? The answer is a hybrid validation strategy. For critical system integrations, use API scripts to simulate a conversation and assert that specific actions are triggered under certain conditions. For natural language output quality, you can actually set up an LLM as a judge validation step in your pipeline. This step evaluates the agent's responses against safety guidelines, ensuring your latest deployment hasn't caused a regression in tone or accuracy. Your deployment is complete, but the work doesn't stop at the release line. In production, agents can experience drift, their real-world behavior can change as users interact with them or as the underlying LLM updates its internal weights. You must monitor key performance indicators, like how often your agent falls back to a human queue or gets stuck in a loop. If an update degrades performance, your CI/CD pipeline needs an automated rollback script. With a single click, you should be able to redeploy the previous stable git commit, restoring the agent to its last known healthy state. Alright, let's wrap up. Here are the key things to remember. Agentforce configurations are composed of discrete, interlocking metadata files, bot, GenAiPlugin, GenAiPlanningRuleset. Deployments require a strict three-phase sequence to prevent invalid reference errors in target orgs. Git branches should isolate changes to specific GenAiPlugins to avoid complex merge conflicts. Post-deployment pipelines must automate activation and implement verification strategies like LLM as a judge. If this helped, hit like, it really helps the channel. Next up, AF_EP22_performance_tuning. See you tomorrow.